Hello everybody, welcome into another lesson. So today we're going to talk about negative exponents. This lesson won't be too bad here, because if we remember from pre-algebra, anytime you have a coefficient, for example, like 3x to the negative second power, that coefficient will always be your numerator. And if you have something to a negative power, what you're going to do is take that variable, put it in the denominator to the positive power. So how that's going to work is that coefficient of 3, that'll be your numerator, okay? Then that x to the negative second, if you have a negative power, you move that x to the denominator, and that negative 2 becomes a positive 2 in the denominator. And that would be your answer for this, would be 3 over x to the second. So if you're ever asked to write it to a positive power, that's how you would do that. You have 3 over x to the second power for your answer. Alright, next one. We have 2n to the negative third. So we have 2n to the negative third. Well, that coefficient of 2, that's going to be your numerator. So then since n is to the negative third power, you're going to take that n, move it to the denominator, turn that negative 3 into a positive 3. So your answer is going to be 2 over n to the third power. Now, on the other hand, let's say we have something like this. You have the whole quantity of 3x to the negative second power. Whenever you have a whole quantity to a negative power, your default denominator would be, your default numerator is 1, okay? You have a default numerator of 1, but you'll take that whole quantity, that 3x, and that's to the negative second power, you'll turn it into the positive second power. So what you have is 1 over 3x to the second power. For the final step, what you have to do now is work in your denominator. Your numerator is going to remain 1, but you'll take that 3x to the second power. Well, 3 to the second power, that's 9. X to the second power, well, that is just that, x to the second power. So the answer you should get for this would be 1 over 9x squared. That would be your final answer. Alright, another quantity problem. We have 5m, that whole quantity to the negative second power. So we have 5m, the whole quantity to the negative second power. Well, you have a default numerator of 1 in that case, but you're going to take that 5m, since it's to a negative power, you'll raise that to the positive second power in the denominator. So now what you have is 1 over the quantity of 5m to the second power. Okay? For the final step, you'll keep your numerator at 1, but you'll take your 5m to the second power. 5 to the second power, well, that's 25. M to the second power is, well, just that. So the final answer you should get for this would be 1 over 25m to the second power. Okay. Another different type of problem. We have x to the negative first, y to the positive second. So we have x to the negative first, y to the positive second. Well, we have two variables, okay? What's going to happen here is that y to the positive second, since it's positive, it stays in the numerator. okay? And since you have a positive power, it stays in the numerator, you almost treat it like a coefficient for all intents and purposes. So what you're going to do, that y to the positive second will stay in your numerator. However, that x to the negative first, since it's to the negative, you'll move that x down to the denominator, and it'll be to the positive first, or we can just leave it as x in the denominator. So your final answer you should get is y squared over x. Alright. We have a to the negative second, b to the negative third. So a to the negative second, b to the negative third. Well, this time both variables have a negative power. However, we don't see a coefficient, so therefore your default coefficient is 1, meaning your numerator is going to be 1, okay? Now, you take your a to the negative second, since it's negative, you'll put the a in the denominator, and that negative second in the denominator becomes positive 2. Same with your b. You have b to the negative third. So since it's negative, you'll put your b in the denominator. That negative 3 becomes a positive 3 in the denominator. So the answer you should get for this is 1 over a to the second, b to the third. Alright, fun one. We have the quantity of m to the negative third to the positive fourth. So we have m to the negative third, that quantity, to the positive fourth power. Well, if we remember the rule for a power to a power, you just take the powers and multiply them. So you would have m, then you have negative 3 times positive 4, that'd be to the negative 12 power. So now you have m to the negative 12th power. Well, your coefficient's 1, so therefore your default numerator is 1. That m to the negative 12th, you're going to move the m to the denominator, and that negative 12 becomes a positive 12 in the denominator. So the answer you should get for this would be 1 over m to the 12th. Similar problem. We have x to the negative second, that quantity, to the positive third power. Well, once again, if we remember the rules for a power to a power, you multiply the powers. So you'll take x to the negative 2 times 3 power, that'd be to the negative 6th power. So now you have x to the negative 6th power. Well, our coefficient's 1, so therefore your default numerator is 1. Then you'll take that x to the negative 6, you'll move the x to the denominator. That negative 6 becomes a positive 6 in the denominator. So the answer you should get for this is 1 over x to the 6th. Alright. We have m to the negative third times m to the positive fourth. Alright, so we have m to the negative third times m to the positive fourth. Well, if we remember the rule for when you multiply two of the same base to different powers, or it could even be the same power, if I have two of the same base, m and m, right? I'm going to keep the base the same, but I'm going to add the two powers together. Negative 3 plus 4 is what? Positive 1, which would just give me m. So the answer I should get for that would simply be m. Alright, we have a to the fifth times a to the negative second. So a to the fifth times a to the negative second. Well, we have the same base, so we keep that, okay? Now when you're multiplying the same base, but you have different powers, you simply add the powers together, right? So 5 minus 2, that would be the positive third power. So the answer you should get would be a to the third power. Alright, we have 3x to the negative second, that quantity to the third power. So this is fun. What you're going to have, you have 3x to the negative second power, that whole quantity to the third. Well, what you do, your coefficient of 3 you take to the third power. 3 to the third is 27. Now you have x to the negative second to the third power. Again, you multiply the powers. X to the negative 2 times 3 is negative 6. So what you have now is 27x to the negative 6. Well, 27 is your coefficient, so by default that would end up in the numerator. That would be your numerator. Now the x to the negative 6, you'll take your x and you'll make that negative 6 into a positive 6 in the denominator, which would therefore render this the answer 27 over x to the 6th. Alright. We have the quantity of 4n to the negative first, that whole quantity to the positive second. So 4n to the negative first, that whole quantity to the positive second. Well, like we did with the last problem, you take your coefficient of 4, raise that to the second power, you'll get 16. Now keep your base n. You have a power to a power, so you multiply the powers. N to the negative first times 2, that'd be n to the negative second. So now you have 16 to the negative n to the negative second power. Well, 16 is your coefficient, so therefore that ends up as your numerator. Now the n to the negative second part, you'll put your n in the denominator. That negative second in the denominator becomes a positive second. So the answer you should get for this would be 16 over n to the second power. Alright, what do we got here? 2x to the fifth times x to the negative fifth. This is a good one. Okay, this is a very good one. 2x to the fifth times x to the negative fifth. Well, I can tell you this. Your coefficients, you just multiply them like normal. You have 2 times 1. Well, that gives you 2. Now, you have the same base x, so we're going to keep your x. When you multiply a base to a power times that same base to a power, you just simply add the powers together. So x to the 5 minus 5 is x to the 0. Well, now we have 2x to the 0. For all intents and purposes, we're going to assume that x itself is not 0. This only works if x itself is not 0. If you had 0 to the 0 power, that would be undefined. But assuming it's not 0 and it's anything else, we know anything to the 0 power except for 0 is 1. So you just have 2 times 1, which would give you an answer of 2. That would be your final answer, would be 2. product here. We have b to the 5th times b to the negative 7, that whole quantity to the 3rd power. Alright, so we got b to the 5th times b to the negative 7th, that whole quantity to the 3rd power. Well, in this case, order of operations dictates we deal with the parentheses first, does it not? Work inside your parentheses. Now, you have the same base b, okay? So you're taking the same base to a power, multiplying it by the same base to a power. That means you simply add the powers together. So 5 minus 7 is negative 2. So what this has reduced to now is b to the negative 2nd power, that whole quantity to the 3rd power. Okay? Now, we have b to the negative 2nd to the 3rd power. Well, when you have a power to a power, what do? You simply just multiply the powers together. You'll end up having b now to the negative 2 times 3 power, that's to the negative 6th power. So you got b to the negative 6th. Now your coefficient's 1, therefore your default numerator is 1. You'll have a numerator of 1 over, now that b to the negative 6, you're going to move that b to the denominator, and that negative 6 becomes a positive 6. So the answer you should get for this would end up being 1 over b to the 6th. Got 8 more problems, then we're done for the day. Alright, we have y over 3, y to the 3rd over y to the negative 5th. So we got y to the 3rd over y to the negative 5th, right? Okay. Whenever you have the same base to a power divided by the same base to a power, what we have to remember is you keep that base, but you subtract. What you're going to do is take the power in the numerator minus the power in the denominator, okay? So you would have y to the 3 minus negative 5. Well, minus negative 5, that's plus 5, right? So you'd have y to the 3 plus 5, therefore would give you y to the 8th. And that would be your final answer, would in fact be y to the 8th power. Alright, let's see here. We have a to the negative 4th over a to the 10th. So we have a to the negative 4th power over a to the 10th power. Well, once again, if you have the same base to a power divided by the same base to a power, what you're going to do is keep the base, and you take the power in the numerator minus the power in the denominator, okay? So we have a to the negative 4th, so it would be a to the negative 4th minus 10. Negative 4 minus 10, that's negative 14. So now we have a to the negative 14th power, which we know we have a coefficient of 1, therefore your numerator is 1. You'll take that a, put it in the denominator, and then that negative 14th power becomes positive in the denominator. So the answer you should get for this would be 1 over a to the 14th power. Alright, we have c to the negative 5th over c to the 2nd. So c to the negative 5th over c to the 2nd. Well, again, we have the same base, so you keep the base. Now you have negative 5 over 2, so that'd be negative 5 minus 2 would be c to the negative 7th. So now we have c to the negative 7th power. Well, your coefficient's 1, that's your default numerator. Now, since c's to the negative 7th, you'll take your c, put it in the denominator. That negative 7 becomes a positive 7 in the denominator. So, final answer you should get is 1 over c to the 7th power. Alright, let's see here. We have d to the negative 3rd over d to the negative 5th. Alright, so d to the negative 3rd over d to the negative 5th. Well, we have the same base, so we're going to keep the d. Now, you're going to end up, since it's division, you'll have negative 3 minus negative 5. Well, minus negative 5 turns into plus 5. So you have d to the negative 3 plus 5. Well, that'd be d to the positive 2. And that would be your answer, would be d to the 2nd power. Alright, 4 more, then we're done. You have, well, better write this a little bit bigger here. A to the negative 6th over a to the negative 2nd, that whole quantity to the negative 1st power. So a little bit of a doozy here. We have a to the negative 6th power over a to the negative 2nd power, that whole quantity to the negative 1st power. Well, order of operations dictates work in your parentheses first. So, what we have here, you have the same base to a power divided by the same base to a power. So you're going to keep your base of a, then you're going to take that negative 6 minus negative 2, which would actually turn into negative 6 plus 2. Negative 6 plus 2, that's negative 4. So that ends up becoming a to the negative 4th, that whole quantity to the negative 1st power. Well, we have a power to a power, so you just multiply the powers now. You keep your base a, you take negative 4 times negative 1, turns into positive 4. So the final answer you should get would be a to the 4th power. Down to 3 more. We're almost done. Alright. We have b to the negative 3rd over b to the negative 6th, that whole quantity to the 4th power. So b to the negative 3rd over b to the negative 6th, the whole quantity to the 4th power. Well, work inside your parentheses first. You have the same base b inside your parentheses, so keep your base. Now, since it's division, you'll take your negative 3 minus negative 6. Well, negative 3 minus negative 6 turns into negative 3 plus 6. Negative 3 plus 6 is positive 3. So you'll have b to the 3rd, that whole quantity to the 4th power. Now, since it's power to a power, you just keep your base and you multiply the 2 powers. B to the 3 times 4, you get b to the 12th. And that would be your answer, would be b to the 12th power. Two more. We have n to the negative 3rd over n, that whole quantity to the negative 2nd power. Alright, so we have n to the negative 3rd power over n, the whole quantity to the negative 2nd power. Again, work inside your parentheses first, okay? You have the base n. Now you have n to the negative 3rd really divided by n to the 1st. So you're going to subtract the powers. That'll be n to the negative 3 minus 1. Well, negative 3 minus 1 is negative 4. So now you have n to the negative 4th power to the negative 2nd power. Now you take the base. Since it's a power to a power, you multiply the two powers of negative 4 times negative 2, you would end up getting n to the 8th. So the answer you should get for this would end up being n to the 8th power. And we've arrived. Last problem. Y to the 5th over y to the negative 2nd, that whole quantity to the negative 3rd. So we got y to the 5th over y to the negative 2nd, the whole quantity to the negative 3rd. Well, again, work inside your parentheses first. You have the base y. So then, since it's division, you'll take 5 minus negative 2, which turns into 5 plus 2, which would be to the 7th. So now you have y to the 7th, that whole quantity to the negative 3rd power. Well, since we have a power to a power, you take the powers and multiply them. Keep your base y. You have y to the 7 times negative 3, that would turn into y to the negative 21st. Well, we still have a negative power to deal with. Your coefficient's 1, so your default numerator is going to be 1. Now that y will go to the denominator since you have a negative power, and that negative 21 becomes a positive 21. So the answer you should get for this would be 1 over y to the 21st power. So that's been it for negative exponents. Next lesson, we're going to start slowly moving into functions and talking about those. We are going to do some equations in 2 variables in the next lesson. So I hope everybody has a good night. Take care.